mathematically speaking, we have to think about how to calculate this vector flux. So let's do it again. Let's have our uniform field here like this. Let's call it an E field this time. Why not? It's electricity and magnetism. And let's have our surface kind of like that, where we had it at a little bit of an angle. Okay? What we have to do mathematically is basically the area has to be a vector. If we're going to capture the strength of this, and the angle in between, we have to actually give it something to represent the angle of the area. And the way you do that is you make it a vector. Okay? So let's be sure we understand how to make an area, which you think of as a scalar, how to make it a vector. So basically then the area vector magnitude equals just the area. You know, if it's 1 meter squared, then the magnitude of that vector is the area. The area direction, the area vector direction is normal to the surface. Okay? So that's how I drew it here. You can see I drew the vector normal to the surface. So now, if we want to define this flux mathematically, first we give it a symbol. Large phi usually means the flux, and you'll usually put something down here that means the flux of what? In this case, we mean the flux of the electric field, so I'll put phi E. The flux in this case is simply the dot product of the E field and the area vector. So if you like to think in Cartesian coordinates and do dot products this way, where it's sort of the x component times the x component plus the y times the y plus a z times a z, that will quantitatively give you the flux, because this dot product will give you a scalar, and flux is a scalar. In most of the problems we do in freshman physics, you want to think of it more in polar coordinates, and you'd write it like this. Phi E, the flux of the electric field, is the magnitude of the E field times the magnitude of the area vector of the A field times the angle cosine of the angle between them. This is sort of the more intuitive example of how to think about flux. This captures all the things I said before: magnitude of E, the size, and the angle. So let's look at a few cases.